Oh, thank you very much for the nice introduction. So my name is Shuichi Onami, and I'm a bit suffering my throat. I got some cold in Montreal, so I'm better. So back to here and spend one night in Japan, and I'm here. I tested the COVID and the influenza is negative, okay? So don't worry about that. Anyway, so I want to start talking about that. So on behalf of the foundingGIDE bioimaging stream team, that's myself is the leading scientist in the SSBD, and Matthew Hartley is the leader of the BIA, and Joshua Moore is the leader of the IDR, and so other foundingGIDE bioimaging stream teams. Okay. Let's go. Okay. So after introduce the kind of the overview of the foundingGIDE, so that's our imaging stream, bioimaging stream, working for this upper part of this figure. That's how we want to integrate the bioimage archive IDR SSBD.3 repository in Europe and Japan, and to unite by using the common or standardized, harmonized metadata model and ontology. So to make it the kind of the interoperability in between those three repositories. That is the main goal. So our goal is we can agree on the enough shared information, and we can agree on the between three repository and enable interoperability and search through. And so we want to also provide the guidance for the setting up new data resources in, beyond our three database. And we're going to make first step toward the structured federation for the ideally worldwide guide. Okay, so. And so the key is the ontology and the metadata model. That is the building block for the interoperability. So those are the ontologies, and is kind of the in the roughly speaking, the categorizing that is study, person, image, and sample, and the instrument for basically the imaging data. But if you go into detail, we have this kind of the a bit and complicated structure and tree. And so I don't want to go into detail, but if you, for example, look into some specific disease, so the thoracic cancer should be appeared in the two different paths. That is the structure of the ontological kind of tree or graph is acyclic, so that's it's a bit kind of not acyclic, so that's difficult to kind of handle. So so we start doing ontologies for data management. So that's usually the ontologies are used in the two kind of specific way. That's for the using for control the vocabulary, and also ontologies a way of provide the semantics of the structured repository metadata. So our common goal is to understand what out there, what in current use, and so look at scope, coverage, maintenance, status of the ontology, and recommended a set of ontologies for use for bioimaging data. So that is the first trial to look into the ontologies. So actually, this is this survey, the landscape analysis of the existing ontologies, and to make a recommendation of the set of the ontologies for the bioimaging data repository is done by the group of the EMBL people and EBI people led by the Matthew Hartley. So so I don't want to not go into detail, but so we already published these derivatives in the notebook, so and in this the URL, so you can check it. So, but I want to bit kind of explain that. That these kind of derivatives, they look into the overview of the currently used ontologies related to the bioimaging data, and so scientific vocabularies listed up and analyzed, and also non-scientific but domain related the vocabulary, such as author's name or such kind of thing. So those are listed up, and also the linked data schema. So they look into the ontologies used in bioimaging related field, and so finally they recommended propose a recommendation for the imaging database, and also the recommendation of the metadata for imaging facility and the steward. So, and those are already uploaded at the Zenodo, so please look into it, right? So, they did it, the ontology analysis, so then move into the metadata model. So the idea is the metadata is also categorized roughly in this kind of thing, but actually the SSBD, IDR, and the bioimage archive use the different metadata models. So to analyze these three different metadata models, so we put together those three models from each database and kind of aligned in the framework of the REMBI. Okay, so REMBI is the framework proposed by the community for metadata and the bioimaging metadata. Right. So, and actually, so some of you attended the last year's our community event in Japan, and so we proposed the first draft of the metadata analysis and the gap analysis, and so we discussed our proposal in the working group, and so get a very good, huge amount of the feedback from the community. So, and I'm very much grateful for this feedback. So, and after this event, we came back to our team and working on that, and continue to kind of refine the metadata analysis. And finally, so we published the report and the metadata model overlap and the gap in between the three repository, and so propose for that. So the basic, this is already published in the Zenodo, so you can download it and check it. So, and published the 23 component that is recommended for use in the repository, and with the controlled vocabulary recommendation. Okay, so I want to a bit closely look into that. So a bit zoom in. So, and actually, so we want to discuss this kind of thing in later today. So, but so please look into the component. For example, the first one is a study description. So, and this should be described in a text, but the author's name should be represented in the ORCID or something like that. So, and the other is organization publications. These kind of the component are commonly used in the 3D repository, and so we are looking into the ontology in I kind of discuss in the first part of my presentation, and propose the format to be used for describing those items. And the other 23rd, the item listed here. So that's so each you can see that each of the important component of the metadata, imaging metadata, and proposed kind of the controlled vocabulary ontology to use for represent it. Okay, that is our the result of the analysis, and also the feedback. Getting the feedback, after discussion of the feedback in the last year. Okay, so we already published it, and so please download it and check it. So we now have proposed 23 components of the metadata to be used commonly in our three database. So, and then we are trying to move on to the next step to interoperate in between those three, the repository. So that's so the first challenge is to make searchable in between the three repositories. So we already started several trials. The first trial we did it is so the very rough, the elastic researches. So that's from SSBD and the bioimage archive. So we can get the very simple simplified version of the metadata from each database to the Omero, the IDR Omero, and so within the Omero team, so they use the Elasticsearch to kind of looking for the data in those the database. And actually, this is an example of the result that's Omero search system. So they found the data in SSBD, and so that's this kind of the Elasticsearch can be done in this simple formula. Okay, so next tested example is we kind of uploaded our data to the OMEZAO in form in the cloud, and so we collected the many large amount of the data set in the OMZAO in the cloud system, and using the metadata of the OMZAO, so they can search for the actual data provided by each repository. So actually, so this the test case. So not only our three database, we embedded the several database in US or other country, and so they provided the data in an OMEZAR form into the cloud system. And actually, so within these the many different data resources, we can search for the data set by using the metadata provided by the ZAR system, okay, ZAR file system. So that's if we can make it the standardized metadata kind of set, so we can do either the ZAR based search or the Elasticsearch based one. Well, anyway, that's so that now we are looking for the discussion about what is actual system to be used for the kind of the cross search system, right? Okay, so and so we also discuss about how to make the kind of the storage or the format of the metadata. So we propose the RO-crate system to be kind of the standardized, kind of not standardized, used for store the data. So that's so all the data should be easily converted into the RO-crate system style. So and so that is kind of easily to share the data in the kind of the interoperative way. So that's our current idea is that those our database the data should be stored in the RO-crate, and then so make the interoperative in that using the RO-crate the foundation, right? So so our current idea is so we will standardize or harmonize the metadata. So and then So the data container should be that's the allocate, and the image format should be OME and ZAL. OME ZAL. So now still under discussion, but we are now trying to move on this way to finalize our goal of the interoperative between our three database, and so also we want to invite the other database worldwide. Okay, so this is the current status of our stream, and in this afternoon, in the evening, so we will have a workshop harmonizing metadata, bioimaging metadata. So this is the hybrid version. So, and we want to welcome you to join today's the presentation and the derivatives. So we want to get the feedback and create the new idea of the future. So please join us our discussion. Okay, so that's all I have today. So I hope to have a good discussion this evening. Okay, so thanks.